Today I'm going to show a demo of the latest Automation Hub feature, provisioning EKS clusters on AWS. Some of the value that this new feature provides are best practices built in, such as providing default namespaces like dev, stage, and prod for workload isolation, setting default thresholds for resource quotas and limit ranges. These restrict containers from consuming large amounts of CPU and memory, as well as native Kubernetes resources. The cluster is also deployed to a private subnet by default. IAM management in the AWS ecosystem can be a full-time job in itself, and the way it has been integrated into EKS is not trivial initially. Out of the box, this feature provides a few external roles, such as cluster admin role and application deployment pipeline role. These roles map to a user inside of the Kubernetes cluster. You could also configure an IAM user in the same manner. Also deployed is an IAM servicer role for each namespace. These map to a service account inside of the Kubernetes cluster. The service roles are deployed as a placeholder, meaning that there are no IAM policies attached. This would be your responsibility depending on the requirements of your container workload. And the end goal is that this would integrate into your existing IAM management process to make this seamless for you. There's no upfront cluster administration work. Future changes can be implemented through the foundational code provided, whether that's on the Terraform or within the code build manifest itself. This is easily extendable. On the back end, you could add additional service accounts or additional cluster roles. You could also add an ingress controller such as Nginx, and even service mesh such as Istio. On the front end, Automation Hub form, you could provide the option to provision a small, medium, or large cluster instead of a single size cluster with each deployment, just to name a few. This particular design integrates Automation Hub with AWS via AWS API Gateway. And that triggers a Lambda function, which invokes a code build pipeline to provision the EKS cluster via Terraform, pulling the source code from Git, storing Terraform state in the S3 bucket. We chose to use code build instead of code deploy because we aren't deploying any application code at this point, just provisioning infrastructure. And with code build, you can bring your own container for the job runtime. This will ensure you have all the tools necessary for the job. Besides Terraform, you may also need EKS CTL or JQ for JSON parsing in Bash, for example. Also with code build, we don't have to worry about hitting Lambda runtime limits, as EKS cluster provisioning does take some time. So I'm going to jump over and actually show you what this looks like. So on the Automation Hub form, I kept this very simplistic for demo purposes. As you can see, we have the option to create or destroy the cluster. We're going to deploy to the default US East 1 region. I'm going to provide my cluster a name. We'll just call this our backend application. The one thing that this does require is VPC and subnets. Again, for the demo purpose, we've hard-coded those into the form, but you easily could add in a drop-down that would allow you to choose which VPC or which subnets to deploy these to. And these values obviously could easily be preloaded into the Automation Hub database, along with other fields, which is probably more typical for an AWS multi-account organizational setup. Other EKS parameters could also be made available from the form. So I'm going to hit submit. And again, this is just sending a REST call over to the API gateway. Lambda function is initiated, and then code build. We should see code build running now. As we do. Build number 75 is in progress, and you can see that the submitter of this was the Lambda job. Okay, as you can see that the code build job has succeeded, so our cluster has been built. I'm going to jump over to the IAM console real quick and show you some of the roles that got created that were mentioned earlier. Things like the cluster admin, so this is a role that me as an external user would consume and be granted cluster admin rights. Here is that deployment pipeline role that your CI/CD pipeline would would assume this role and be able to deploy your applications into the cluster. We have a viewer role for each one of the namespaces. So that gives an external user just view capabilities on a per namespace basis. Same thing with the service role. So this is the service role that would map to your Kubernetes service account for that particular namespace. And if I jump over to the actual cluster itself, I can show you a few other things over here. So we'll look at the namespaces. As you can see, besides the default ones, we have the dev, stage, and prod ones that we deployed. Let's take a look at the resource quotas that we also talked about being deployed for every namespace. And again, we only have these for our custom namespaces. These don't apply to the default namespaces, so that's why you only see dev, stage, and prod here. But you do see we have resource limits on both CPU memory, which are container pod level resources, as well as some of those native Kubernetes resources like config maps and pods themselves. And I'm also going to show you the mapping of these external roles that I just showed you from the IAM console and how they map to the internal cluster users. So as you see, we have our deployment pipeline, these viewer roles, the admin role, and then they map to a user inside of the cluster or potentially a group, depending on how you set it up. And then from there, these users, you would use native Kubernetes RBAC to configure what these users have access to inside of your cluster. And lastly, I want to show you the mapping of the service role to the Kubernetes service account. So we do create a default service account for each namespace. So if we look at the dev one, oops, we need to dump that out. Okay, so as you see, we have this annotation, and this is just how AWS implemented this within EKS. So this service account now is mapped to the dev service role. So then the service role is where you would attach your policies and give access to whatever AWS resources this particular workload would need that is using the dev user service account. And with that, that concludes the demo of EKS provisioning inside of the Automation Hub.